Hi everyone. So for this video I want to talk about converting from general form to vertex form for quadratic functions. So what that means is when we have a function in general form, we know it looks something like this: ax squared plus bx plus c, and we're going to convert it into a form that looks like this: a times x minus h squared plus k. So what we have on the left, and we've seen in previous videos, is this is called our general form, and this over here is called our vertex form. Alright, so we have a couple different letters. So in the general form we have the letters A, B, and C, and in vertex form we have the letters A, H, and K. So our A here, we're using the same letter A for a nice reason, and that's because they're always going to be the same number. So this is our leading coefficient, so this A we call our leading coefficient, and it will always be the same as this A over here, which is why we're using that letter. But the H and the K will be different. And so what we get from vertex form is we get some information. Specifically, the point HK is the vertex of our parabola. So we call that the vertex. And as we've seen in class, that when we graph this, the vertex always appears as either the highest point or the lowest point on the parabola. So when we're thinking about modeling, this often gives us our optimal value. If we're looking for the maximal output, we can find that at the vertex for certain parabolas, and if we're looking for the minimal output, we can also find that at the vertex for certain parabolas. So it's of interest to us here. All right. So also in class, what we discovered, we had a series of explorations to figure out how do I come up with some formulas for H and K. So if you haven't gone through the explorations yet, what I would do is have you pause the video and go look at those worksheets and try to think about the values for H and K on your own. Okay, so if you want to do that now, this would be a good time to pause, because I'm going to write them down here so we can move forward. All right, so in class, what we found was that if I'm going to compute H, what I need to do is look at the formula negative b divided by 2a. So this b and this a come from our general form, so we're using this a here and this b here. So past that, once we have our h value, and once we know what it is, we can go over here and compute k as f of h. So h is negative b over 2a, and k is going to be found by plugging h back into the general form for our quadratic function. Right, so we have these formulas here, and a brief overview. So for the rest of the video, I just want to walk us through two examples. So I'm going to take an opportunity to clean everything up, and we'll come back with an example. All right, so we're back, and I have an example for us here. So my function is f of x equals 2x squared plus 12x plus 13, and we can see that it's in general form, and what I want to do is I want to convert it to our vertex form, which I wrote up here. So ax minus h squared plus k. So if I'm going to figure out what my vertex form is, what I need to do first is identify all of my different letters and what their values are. So the first thing I notice is that the coefficient on x squared, which we call a, that's equal to 2. The coefficient on x, which we call b, that's equal to 12. And the constant term, which we call c, that's equal to 13. So a is 2, b is 12, and c is 13. So if I'm going to compute h, what I do is I plug in these numbers. So I get h is equal to negative b over 2a, which is above there. So the first thing I do is I identify b, which is 12, and then I divide that by 2 times my value for a, which is 2. And so when this all comes out, what I see is 12 divided by 4. So this is negative. 12 is my numerator. 2 times 2 is 4. And that's negative 3. So this is pretty good so far. I have my value for h, and now I just need my value for k. And so what we have is k is equal to f of h, but in this case h is equal to negative 3. So what I'm going to do is I'm going to put negative 3 here in my function. And so what we're doing is we're taking this negative 3 and we plug it in down here. All right? So I want to know, what is the output of my function when I evaluate it at negative 3? And so where I'm going to go is I'm going to come back up here to my general form. So this is the equation of my function, and I'm going to plug negative 3 back in to that function and see what I get. Okay, so I get 2 times x squared, x in this case is negative 3, plus 12 times x, which is negative 3, plus 13. Okay, so negative 3 squared is 9, so this is 2 times 9, minus 12 times 3 is 36, plus 13. So this is 18 minus 36 plus 13. So if I put all of this together, what ends up happening is I get 31 minus 36, which is negative 5. Okay, so I have h is equal to negative 3, I have k is equal to negative 5, and I have a as equal to 2. So I'm going to come over here to my vertex form, a times x minus h squared plus k, and I'm just simply going to plug in my numbers. Right, so I have a, h, and k. So a was 2. X minus, well, h, I come down here and I look, is negative 3. So that's x minus negative 3 squared plus k, well, k is negative 5, so I put that on the outside. And so if I am simplifying all of this, what I get is 2 times x plus 3 squared minus 5. Okay, so we're getting a little bit cramped here, but that's okay. So this is our final answer. So our final vertex form is this right here. So I'll highlight it. Right, so we get 2 x plus 3 squared minus 5. Right, so if I want to convert from general form to vertex form, what we discovered was that using these formulas, h is negative b over 2a and k equal to f of h, these are very nice for us. So they help us out with our analytic work quite well. All right, so what I'm going to do is pause this video, clean it up, and then we'll come back with one more example. All right, we are back with our next example. I have my function g of x, which is 3x squared minus 12x plus 16, and my goal here is to convert it into my vertex form. All right, so at this point, what would be great is if you haven't worked this out yourself, you can pause the video here, try to do it on your own, and then we'll come back and work on it together. All right, so take that opportunity here now. So the first thing that I'm going to do is I'm going to identify a, b, and c. So in this case, a is equal to 3, b is equal to negative 12, and c is equal to 16. So this is the starting point for me. This gives me all of the numbers that I need, and once I think about my formulas for vertex form, that's going to give me all the numbers so that I can actually write out the correct vertex form and have my conversion. Right, so what we need to remember is those formulas that we had for h and k. So the big thing here is to remember that h is equal to negative b over 2a. Okay, so what I'm going to do is plug in my numbers here. So this is equal to negative, and for b, what I get is negative 12. So this is negative 12. And I'm going to divide by 2 times a, which is 3. So when I think about this, I have 2 negatives, so that's going to make a positive. And so I'm going to get 12 on top and 6. And so what I get here is that h is equal to 2. So step 2, we're going to find k. So if you remember, k is equal to f of h. So what I need to do is take this value that I have here, 2. So I have 2. And I need to plug it back in to my original function. Okay, so in this case, what I have is I said f of h, but we don't have f, right? So what I'm going to do is I'm going to replace this with my new function name. It's really g of h. Okay. And so in this case, what I want to do is find g of 2. So we come up to our g of x, and we say, okay, well, g of 2 is going to be 3 times 2 squared minus 12 times 2 plus 16. So this is 3 times 4 minus 24 plus 16. And so this is 12 minus 24 plus 16. What does that come out to? So I get 28 minus 24, and that is equal to 4. So I have my next piece of information that's important. I have that k is equal to 4. So I'm going to scroll down here to give us some more space. So vertex form, if we think about it, a times x minus h squared plus k. I have to go in and plug in my numbers. So at the top of our screen, we can still see that we have a, so we saw a is 3. We see it here and here. So a is 3. So I'm going to plug that in. So this is equal to 3 times x minus. Now I think about h. Well, if I come up to the top, h right here. So h is 2. X minus 2 squared plus 4. So 3x minus 2 squared plus 4. Right, so what I've done is I had my original function, and I've now successfully converted it into vertex form. So if you want to check that this is correct, what we can do is we can go ahead and FOIL this out and see if we get back to the same thing. Or another way would be to plug both of our functions into Desmos and see if they're actually the same. So it's always great to check. We have lots of resources at our disposal so we can check that these things are correct. All right, so I hope this helped, and I'll see you next time.